Now we have the multiplication rule as a method of finding probabilities that can be expressed as the probability of A and B. The probability that event A occurs in the first trial and event B occurs in a second trial. So let me point that out to you. When we're dealing with the probability of A and B, one, the keyword and will not necessarily be in the problem, but look for more than one trial, okay, where you're selecting two of one thing, or three, or four, or more. When we were dealing with or probabilities, where your keyword was or, the word or was always in the problem, and we were only having one trial. Now we have and probabilities where we're going to have to multiply, and will not necessarily be in the problem, but look for problems with more than one trial. Definition: two events are independent events if the occurrence of either of them has no effect on the probability of the other. So in that case, we'll use the probability of A, and the probability of B is equal to the probability of A times the probability of B. Now, dependent events. Two events are dependent if the occurrence of one of them has no effect on the probability of the other. Sorry, has an effect on the probability of the other. The fact that A occurs changes the probability of B. So when we look for probability of A and B and we have dependent events, we'll have to take the probability of A and multiply by the probability of B given that A has occurred. Now, we have this line going straight up and down here that is not a division line. It means given. That is mathematical shorthand for the word given. So we read that, the probability of A times the probability of B given A. So, with replacement or without. Situations where we take an item and then replace it before taking the second item are representative of what we call sampling with replacement. Situations where we take an item and then do not replace it are called sampling without replacement. When you're sampling with replacement, the two events are independent. When you're sampling without replacement, then the two events are dependent. That's where the probability of A is going to affect the probability of B. Let's look at some examples. A U.S. roulette wheel has 38 numbered slots, 1 through 36, 0, double 0. 18 are black, 18 are red, and 2 are green. The ball can land on any slot with equal probability. What is the probability of red occurring on 2 consecutive plays? So, we don't see the word and in this problem anywhere. However, we said that we have 2 trials. We're looking at 2 consecutive plays. So, actually what we're trying to find here is the probability of red occurring and red occurring. So, the probability of 2 red. Now, on the first trial, the probability of red, since there are 18 red, will be 18 out of the total of 38. Now we have to ask ourselves, if we get red on the first trial, does that affect the probability that we get red on the second trial? And the answer here is no, it doesn't, because one spin does not affect the probability of what you get on the second spin. So, we again have 18 over 38 for the probability of red occurring on that second trial. Another way to write that is 18 over 38 squared, and that rounded to 3 decimal places is 0.224. Example 2. There are 20 chocolates in a box, 5 of which are chocolate-covered cherries. What is the probability of choosing 2 chocolate-covered cherries when they are selected without replacement? So the word there, or keyword there, is without replacement. We have 2 trials without replacement. These are dependent events. So the probability of 2 chocolate-covered cherries. The probability of choosing 1 on the first trial. There's 5 chocolate-covered cherries out of 20. Now, we've eaten that one. We picked it, we ate it, it's gone. Okay? So we only have 19 chocolates left in the box, 19 total to choose from. So that goes on the bottom for our second trial. And since the first one we selected, we get to assume it was a chocolate-covered cherry. And remember, we ate it, so it's gone. There's only 4 left. And so when we multiply that together, we get 20 over 380. You can reduce that to 1/19, or 0.053 for 3 decimal places. And remember, if you want to convert a decimal to a fraction on your calculator, put the decimal into the calculator and hit math, and then select 1 and hit enter, and it'll convert it to a fraction for you. Now, next example. Find the probability of 9 girls being born in a row. So, we have more than one trial. This is going to be an AND probability. We have to ask ourselves, does the fact that we have a girl born in one trial affect the probability of a girl being born in another trial? And no. The answer to that is no. So, the probability of 9 girls. Well, first, let's figure out what's the probability of just having one girl. Well, you either have a girl or a boy, so that's 1/2. So the probability of having 9 girls would be 1/2 multiplied by itself 9 times. But another way to write that is 1/2 to the 9th. And if you take that and raise it to the 9th, rounding to 3 decimal places, 0.002. Next example. 3 people are randomly selected, 1 person at a time, from 5 freshmen, 2 sophomores, and 4 juniors. Find the probability that the first 2 people selected are freshmen and the third is a junior. Now, the word without replacement is not in here, but we need to assume without replacement because it doesn't say with replacement, so we have to assume without replacement. So, we want the probability of selecting 2 freshmen and 1 junior. Well, in our first trial, when we select that first freshman, we have 5, 6, 7, 8, 9, 10, 11 people to choose from total. And the number of those that are freshmen are 5. So we chose that freshman and we set that person over to the side, so he's no longer in the group. So then we only have 10 people and 4 freshmen to choose from. Now we still need to choose the junior. And since we took that second freshman that we chose and put him over to the side, or her, there's only 9 people left to choose from, but there's still 4 juniors left because we haven't chosen any of those yet. So now we multiply that across on top, across on bottom. That's 80 over 990, which reduces to 8 over 99, or if you want to write that as a decimal, 0.081. Now in your homework, you'll be given problems where the information is set up in a table for you. So let's look at a couple of those. We have the same table as before: non-smoker, light smoker, heavy smoker, men and women. The question is, if 2 people are randomly selected without replacement from the 941 subjects, find the probability of selecting 2 women. Now this is without replacing them. So look at the total number of women, That's 459. Out of the total number of people that you have to choose from, which is 941. Now we pick that person, they aren't replaced. So when we choose another person, there's only 458 women to choose from and 940 total people left. And we're going to multiply across on top, across on bottom, and divide. And we get 0.237665. And rounding that to 3 decimal places, it's 0.238. Now, in part B, we're selecting 2 women again, but this time it's with replacement. We pick one, we get to put them back in. Okay? So, if 2 people randomly selected with replacement, the first time we select one, it'll be 459 and 941. Now we take that person and put them back in the group, and so we still have 459 women to choose from with 941 total people. Multiplying that out, we get 0.237928, etc. Again, we round that to 3 decimal places and we get 0.238. Now, on this problem, we got the same answer as the previous one. But that's because our sample is so large that when we're only choosing 2 people, it's almost like the events could be independent because the sample size is so large and we're only choosing 2 of the 941. If your sample was not that large, if it was a much smaller sample, then that would not be the case.